Hi Vamshi, welcome to EduE Master.
Hi,
How are you?
I'm good. How about you?
I'm good. Okay, first let me introduce myself. Okay, I'm Priya, your SAS
Oh,
trainer. Okay, I'm working as a SAS programmer from past five
okay.
years in one of the MNCs. Can you introduce yourself?
Mm-hmm. Yes, I completed my BTech.
Good. Then how you know about SAS?
One of my friend suggested me about SAS.
Okay, good.
Okay, before starting class, I had a few questions.
Oh yeah, tell me.
As I'm from engineering background, can I learn SAS?
Yes, you can. See, people from any background can learn SAS. Okay, it doesn't matter with the educational background. Even a pharmacy student or an engineering student or a nursing or people who have completed their MBA, everyone can join it in SAS.
What about the job opportunities?
See, there are plenty of job opportunities, okay, because nowadays SAS is used in most of the sectors like pharmaceutical, automobiles or banking, like this. Okay, so
Okay.
you can choose your career in any of the fields. Okay, either you can go for the
Mm-hmm.
banking side or you can go for the clinical
Okay.
side, like you can join in any pharmaceutical company as a SAS programmer. As a SAS programmer you can
Okay.
advance your career also.
Okay. Uh, okay. And I also heard the salary is also good for SAS programmer.
Yes, that's true, Vamshi. As a SAS programmer you can earn good. Okay, if you go for the contract positions it's more
Okay. Yeah.
than the permanent ones. Hmm.
Okay.
Okay, anything else?
Mm-hmm. Okay. Yeah. Nothing. Can we start the class?
Yes, we can. Let's see the introduction of SAS. Okay. So,
Okay.
what is SAS? The full form of SAS is Statistical Analysis Software or System. Okay. It was developed
Okay.
at North Carolina State University from 1960s to 1970s. And later
Mm-hmm.
on in 1980s and 1990s, they have developed furtherly. They added some extra procedures. Okay.
Okay. Yeah.
And it is a computer programming language. We can use SAS for managing the data or we can do some manipulations in that. Okay, we can perform data
Okay.
analysis and also we can generate different kinds of reports like tables, listings and graphs. Okay, graphs
Mm-hmm.
or figures, either way we will call them. Okay, so
Okay.
TLFs means tables, listings and figures or tables, listings and graphs.
Okay.
So in SAS it includes proc SQL also. Okay, so we can
Okay.
perform SQL queries on our SAS data files.
Okay.
Okay.
Priya, have you got any competitors for SAS?
Yes, we had many competitors. Okay, I'll tell you. Okay, like Informatica,
Okay. Yeah. Mm-hmm.
Informatica, Teradata, Cognos,
Okay.
SPSS.
Mm-hmm.
Okay, and also Cognos. Like this, it is having so many competitors. Okay,
Okay.
but how SAS is overcoming all those things?
Mm-hmm.
Okay, because see, SAS can perform three works. Okay, it can do data
Okay.
management.
Yeah. Mm-hmm.
Okay, also it can analyze the data, it can perform analysis, it can generate
Okay.
different kinds of reports.
Okay.
These three works SAS can do, but all the
Mm-hmm.
competitors cannot do all these works.
Okay.
If you take
Yeah.
Informatica, this is only the data management tool,
Okay.
but it cannot perform analysis and it cannot generate the reports. Okay, same way.
Okay.
Cognos, it is only the reporting tool. It cannot do these two works, data
Mm-hmm.
management and analysis. Okay, like this.
Okay.
SPSS,
Yeah.
it is only for the analysis. Like this, all these
Okay.
competitors cannot do all these three works. Okay, but SAS can do all these three works.
Okay. Yeah. Got it.
Okay, okay. So, see, in 1880s and 1890s, they are using Pascal and COBOL. Okay, later only
Okay.
we got
Mm-hmm.
C, that is second generation.
Yeah.
After C we got C++, right? So C++,
Okay.
.NET, Java, all these are the third generations. But now the
Okay.
current one, fourth generation is the SAS.
Okay.
Okay. I'll show you the
Yeah.
SAS software, how it will look like. Can you able to see this icon?
Yes. Yeah. I can see it.
This is the SAS software. Okay, the current version is 9.4. I'm using 9.4.
Okay.
Okay, whatever the
Mm-hmm.
version is, we
Okay.
can do works. We can generate the reports even in this 9.2 or 9.1 also. Using SAS, we can do data management. We can manipulate some data. Can analyze the data. Analysis can be done, and we can generate reports. SAS programmers will process the raw data. They'll process, they'll analyze, and then they'll create an analysis data sets using which reports can be generated. These reports are of three types. One is tables, listings, and then graphs or figures. We'll simply call them as TLFs or TLGs. Now let us understand the SAS software. If you open SAS, it will look like this. See, at the bottom we can find some windows: editor, log, output, explorer, and results, right? So this SAS will contain 5 windows. First one is editor window. Second one, log window. Third one, output. Next, explorer, and then the results. Let's see the significance of each window. First, editor window. Using this editor window, we can write some programs, or we can edit already existed programs. This is the window where we can write. I'll just write a simple program here. See, data, new, input, name, age, gender, and I'll give some values for that. Sorry. So this is the window. Here I wrote some program, right? So editor window is used to write program. Okay, next coming to the log window. Whatever the information is there about your program, it will be displayed in the log window. Now I'll submit this program and we'll go to log window and see here it is showing our codes what I have written. Right here I have written data, new input, some information I have written, cards, and then run. The same thing it is showing here, and also in blue color it is showing some notes. Some execution details will be displayed. Mainly this log window will displayed in 4 colors. One is black, next one is blue, next one is green, and then red. Okay, what will be displayed in black color? As I already told you, these codes. These codes will be in black color. In blue color, execution details will be displayed. When coming to the green, it displays warnings in green color. Okay, see here, data spelling, instead of DATA, I am writing as DAT. And now I am executing this. Go to log window and check. See, it is giving us a warning. What it is telling? Assuming the symbol data was misspelled as DAT. It is highlighting and then it is giving us a warning. So by seeing that we can rectify our mistake. Same way, if our program is having any syntax errors, it will be displayed in red color. See here, I am removing this semicolon next to cards. Now I am executing. Go to log window and check. See, it is telling an error. Syntax error expecting one of the following. What? Semicolon is there, right? So give semicolon and now execute. Now your program is perfect, no errors, right? So this log window shows you these four colors: errors in red color, warnings in green color, execution details in blue, and codes in black. So this is about a log window. Now coming to the output. If you want to print any report, if you want to generate any report, it will be displayed in the output window. Now let's print this data. Don't worry about how to write all these things. I'll explain in detail later. Continue. Okay, now I'm printing this report. Select and submit. See, by defaultly it is coming in an output window. This output window is opening by default. To open an editor window, I'm clicking here. To open output window also same way we can click here, but if we submit, if we print any report, if we generate any reports, if our program is correct without any warnings or errors, by default it will output window will open. See, output window is open and my data is printed here. What is there? Here I am having name, age and gender and some values. The same way it is printing here. Output window is used to display our reports. Now coming to the Explorer. This Explorer window will have four folders: computers, favorite folders, shortcuts and then libraries. In this, libraries are the important one, because whatever the data we are storing, that data will go and save in these libraries. Now coming to the, let's see in detail about libraries later. Coming to the results window. Results window is used to navigate your output window. This output window will show you the current report. Suppose in a day, if you have executed some 20 programs, and after executing 20th program, if you go back and check the second program or first program, then it will be difficult for us to scroll here, output window. But using the results window, we can navigate our output window. Just simply click on that second one. If you want to open first one, click on first one. Okay. So in this result window, all the procedures what we executed will be shown in a tree-like manner, one by one. If I print one more time, the third time it will appear. Same way, fourth time it will appear. Like this. So this is about our windows. Now coming to the SAS files. SAS contains two files. One is called dataset, another one is called catalog. We can store our data either as a dataset or like a catalog. It depends on our coding. Let's see how a dataset will look like. See this, these white ones we'll call them as datasets. These yellow ones we'll call them as SAS catalogs. SAS datasets and then SAS catalogs. Now let's open one dataset and then see. See, this is my dataset which I have created now. Okay, in this dataset I have given name, age, gender and some values. Okay, open this dataset. See this how it is looking like. It is looking like a table. In table we'll have some columns and also rows. Here we should not call it as columns and rows. In SAS we have to call them as variables and observations. Columns are called as variables, whereas rows are called as observations. So here I am having 3 columns, means 3 variables, name, age and gender. Same way this complete row will call it as one observation. So first observation and this is a second observation. 2 observations are there here. If you observe the log window, it is showing the same, right? So my dataset name is new. This new contains has 2 observations and 3 variables, right? 3 variables, name, age, gender and 2 observations, first one, second one. Now coming to the SAS programs. It contains 2 steps. One is called data step. Another one is called proc step. Data step is nothing but it starts with the keyword data and ends with run. So this is one data step. Same way proc step means procedure step is nothing but starts with the word proc and ends with run. This is an example for proc step. Like this we'll have different procedures. This is a print procedure. Same way in procedure step we'll have different procedures like frequency, sort, contents, etc. What is the use of this data step? Now see this, I am deleting this one. Now observe at the left hand side. This data step I am submitting. So what it is creating? After execution of this data step, it created a data set. This is my raw data. This data I kept in my data step. Raw data is kept in data step, and by executing this data step we can generate a data set. So what is the use of data step? We can generate or we can create data sets using our data. Now coming to the proc step. What is the use of proc step? Using proc step we can generate reports. We can process our data set using proc step and we can generate reports. See this? If I am printing, it is giving a report. So now from this data set, using proc step, reports can be generated. This is the workflow of SAS. Whatever the program we write in SAS, it will be mainly or data step or in a proc step. Most of the programs will be like this, either in a data step or in a proc step. Now let's see the dataset in detail. This dataset will contain two portions. One is called data portion. Another one is called descriptor portion. What is meant by data portion? Data portion means it contains data. The word itself is telling data portion or descriptor portion. Means it contains the description. It tells about the data set. Let's see the data portion. How to browse the data portion? If you want from this data set, if you want to check the data, how to browse the data? Using proc print procedure, we can browse the data portion. This is an example for that. Write proc print data equals to your dataset name and then run, submit. See, it is displaying you the data present in that dataset. Right, so this is called the data portion. The data is name, age, gender and values for them. Vamshi, age is 45, gender is male. Same way this second observation also. So using proc print we can browse the data portion. Then what is descriptor portion? Descriptor portion is nothing but it gives a general information about the data set. Means how many observations it contains, how many variables it contains, whether it is sorted or not, when it was created, where it is stored, what is the dataset name, all the general information. How to browse this descriptor portion? Using proc contents. It is very simple. Just replace this word with print word with contents. Proc contents data equals to dataset name, run. Now select it and submit. See, it is giving you the contents. What is the dataset name? New. Where it is stored? In my work library. How many observations are there? 2. How many variables are there? 3. See? How many variables? 3 variables and 2 observations. What are my variable names? Name, age and gender. Right? Same way it is showing your variables in an alphabetical order. Age, gender and name. Also it is showing you the type also. Let's see about this. Okay. This descriptor portion is nothing but the general information about your dataset that can be browsed using proc contents procedure. If you observe the result window, see, previously I have printed the report. I have used proc print procedure, so it is showing print. Now I have used this contents procedure, so here it is showing you the contents. Right? So now let us see some variable attributes. Let's see variable in details. What are my variables? And also there are some rules to write these variable names or a dataset name. Okay. We'll call them as naming convention rules. First let us see the variables and then we'll see the rules. Okay. Double click on your dataset, it will open. Say here your variables name, age and gender. Double click on any of the variable. See, it is opening a box like this. Here all the variable attributes will be present. Okay, there are different attributes called name, label, length, format, informat and type. Let us see each in detail. There are 6 variable attributes. They are label, first one is name, label, length, format, informat and then the type. What is name? Name is nothing but your variable name. My variable name is name, age, gender. So these are your variable names. Label. In variable name we cannot give lengthy names. So if your variable is having lengthy name, the short form you will mention in this the name, and then you'll give the description as a label. Coming to the length. For each variable, there are length will be set as default. Okay, first let's see the type. Variables are of two types. One is numeric and second one is character variable. What is meant by numeric variable? Numeric variable means it contains only numbers. If you see this, in this age is my numeric variable, right? Here it is containing only numbers. When you see this name and gender, it is a character variable. Numeric variable should contain only numbers, whereas character variable can take numbers, characters, or alphanumeric also. By default, the numeric variable can take 12 characters length. If it is more than 12 characters, it will be read in an electronic format. Now let's see. 12 characters length means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here 12 digits are there, right? 12 characters. So till 12 characters it will read normally. Try to print this one, you will get the complete number from 1 to 2. If you increase more than 12, just give one more and see. It will read in an electronic format. See, it is coming in an electronic format and some decimals, right? So by default, the numeric variable can read up to 12 characters. But coming to the character variable, by default the length will be set as 8 characters. Okay. Mean if you give more than 8 characters, let's see what will happen. Vamshi Kumar. How many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Till M, 8 characters are there. So A and R are more. So if it is having more than 8, it will truncate the data. It cannot read these extra characters. Print this and see. It is giving till M. It is truncating the A and R. So if you want to read this complete data, you can increase the length using the length statement. Okay. Now format and informat, let's see them later. Using the length statement, we can increase the variable length. So these are 6 attributes that each variable will contain. Same thing, if you go for the contents, here also it is showing all you that variables, right? So type and length it is showing here. Age is a numeric one because it contains only numbers. Gender and name are the character ones because it contains some letters. How to differentiate numeric and characters? By seeing here, we can understand this is the letters and these are numbers. But SAS, how it will understand? So to differentiate character variable and numeric variable, we'll use $sign next to the character variable. So wherever $sign is there, SAS will consider it as a character variable. If you observe, next to name I have given $sign. Next to gender also I have given this dollar symbol. So SAS is considering these two as a character variables. If you want to check, open this data set, go to this one. See, name is a character one. Same way, if you check the age, this is a numeric. Gender, again it is a character type. So all those will be displayed in a variable attributes. Now coming to the libraries. As I told you, libraries are the storage place for your SAS files, right? Now libraries. Whatever the data you are storing in SAS, that data will save in libraries. Libraries are of different types. Storage place for SAS files. There are different kinds of libraries called SAS help, SAS user, and then work. These three libraries will find in default when we install SAS. What is the SAS help, SAS user and work? SAS help is the permanent library. System created permanent library. System defined or created permanent library. Whereas SAS user is a user created permanent library. These two are the permanent libraries. SAS help and SAS user. Whereas work, this is the temporary library. What is this permanent and temporary? Nothing but whatever the data you are storing in SAS help and SAS user, they will be stored forever. Until unless you delete, the data won't get deleted. But whatever the data you are storing in work library, this is only for the temporary purpose. If you end this SAS or if you close this SAS, the data saved in this work library will get deleted. We can create some libraries. How to create a libraries? Using a libname statement we can create. Write libname. Just give one reference for your library. Means name, work, perm, SAS help, SAS user maps. All these are my library references. Same way, just give one library reference. Like Apple. Okay. Next, in quotations we have to mention some location. If you observe, just right click and go to properties. This library is connected to your system. At backend it is linked to your some path. It is linked to some C drive users, all those things. Okay. Like that each and every library will be linked to one path. Okay, that is nothing but file location. So just give one file location. I'll give this location file path. Okay, now run this. See, an Apple library is created. Now how to store your data in these libraries? This is my data set. Data. If you want to store data in any of these libraries, just simply mention the library name SAS help.new or SAS user.new. If you run this one, this data set will go and save in your SAS user library. Okay. If you mention work or if you don't mention work also, both are similar. Even if you give work dot or if you didn't give work dot also, the data will go and save in your work library for the temporary purpose. So if you want to save in your permanent libraries, if you want to work with the data in future also, save in permanent libraries like SAS help dot or SAS user. This is two level names, giving the library name as well as dataset name. Both names will be separated by using a dot. This is one level name. Here we'll write only the dataset name. Now again let's go back how to save in an Apple library. If you want to save, here I created an Apple library. If you want to save that one, just give the library name apple.new. Run this one. check. See here my Apple library. Now I got this new data set. If you go back and check this path, as this library is linked to this path, this dataset will also be saved in that path. See here I got this new dataset. Same way you can create libraries using another method also. This that is called by clicking this new library method. By clicking this new library button, you can create libraries also. So here give some library reference. Orange. Browse the path. OK. Click OK. See here orange is created. Same way if you want to save, you can give orange dot. Okay. You can create libraries using these two methods, either by using this libname statement or by clicking this new library button. Whatever the libraries you created using these two methods are the temporary libraries. If you close this SAS, these two libraries will get deleted. But how to create a permanent library? You can create a permanent library also by clicking this again new library button, give some name ABC, browse path as before how we did. See this enable at startup button, click this one. If you enable this one, then this will become a permanent library. Now click OK. So now if you close, this ABC won't get deleted, but Apple and Orange will be deleted, and also the data saved in those libraries will also be lost. This is how we create our libraries, and we'll save the libraries by giving our library name before the dataset name, and these two names will be separated by using a dot. Now let's see how to submit a program. If we want to submit any program, just select the code, and click on the submit button. So there are so many ways of submitting a program. Either you can click on this submit button, or you can press F3 or right click and then submit selection, and the fourth way is you can type here submit and just enter. You can choose any of the ways in these four methods. Now coming to this semicolon. What is the semicolon? Semicolon will call the test statement terminator. Till here this is one statement, because here I have used this semicolon, so this is one statement, this is another, this is the third statement, and this is the last one. Now let's see the naming convention rules. To give this library name or dataset name, or to give the variable names, we should follow some rules. Let's see them. First one, let's see for the variable names or dataset names. There are four rules we should follow. We should keep in mind when creating the variable name or the dataset name. First one, it should start with either character or underscore. See here my dataset name is new. It is starting with the character, or it should be like this. It should start with either underscore or character. Same way for the variable name also. It should start with either character like this, or it should start with underscore. Second one, should not use numbers at first position, but you can use in any other positions other than the first position. You cannot give your variable name like this, 1 or age 2. You cannot give like this, but instead of giving at the first position, you can give numbers at any position. You can write here or you can write in between, anywhere. Now third one, should not contain any other special characters. Should not contain special characters except underscore. Except underscore. Special characters are nothing but all these symbols. Even blank space is also a special character. So your dataset name or the variable name should not contain any special characters, like all these symbols. Okay, except underscore. There is an exception for an underscore. Okay, now the final one. It should not be more than 32 characters long. If you are having more than 32 characters, then it will become an invalid name. So you can give a short name here as a variable name or the dataset name, and the big one, the complete description, you can give in this label. So these are the 4 points we should keep in mind while we are writing a variable name or the dataset name. Let's see some examples. See here, I am writing this name, age, gender like this, right? So these are the valid SAS names. If I give like a student, this is a valid SAS name. Class, this is a valid SAS name. So all these are the valid SAS names. Okay. Same way, if you write like this as a student, one student, or if you use any symbols, then it will become an invalid SAS name. Just here, give one age, and now run this. Go to log window and see, it is giving an error. Or right here, 1 is a dataset name. Go to log window. See, it is showing an error, right? It is highlighting here and it is telling the symbol is not recognized, because we should not use numbers at first position. So if you violate any these rules, then a warning or an error will be displayed in a log window. These are the naming conventions for the variable names or the dataset names. Same way, we have some rules for library names also. While creating the library names, we should keep them in mind. They are same like this, but except instead of 32 characters, it should be only 8 characters long. Remaining everything is same. So now variable names, library names. Here it should be only 8 characters long. Then remaining all are same for the variable names and for the dataset names. Now let's learn how to create a dataset. In this, what is the use of each statement? Here let us create another dataset. Data new one. Input, give some ID, salary and then age. salary ID, declare it as a character one. It's not a mandatory. Give P101 salary 1000, age 25. P102 2035. Like this. See, now let's see what is the use of the keyword data. Using this keyword data, we can create a dataset name. Whatever the names I'm giving here in this data statement, it will be created as a data set name. Now if I execute, it will create one dataset name, one dataset called new one, right? Previously here I have written new, so it created a new dataset. Here I have given new one, so it created a new one dataset. So this is the use of the keyword data to give a dataset name. What is the use of this input? Using this input statement, we can create variables. So whatever the names you are writing here, they will be considered as a variables. Using cards or data lines, we can write both. Both are same. We can assign these values to these variables. So this P101 as an ID, salary 1000 and then age 25. This is first observation. Now next one, P102 2000 and 35. This is the second one. So using cards or data lines, we can assign the values to the variables. This single line will call it as a single observation. If you take as a single values, we'll call them as a data value. So this is one data value, this is one data value, like that. Now run this, open the data set, same. Whatever the data we have given, it is displaying in the data set. Suppose if our variables is having any missing values, then how the numeric variable will represent it, and then how the character missing values will be represented. Now I'll miss this one, same way I'll miss one numeric variables. Okay. Now print this one. Proc print data equals to, give your dataset name and end with run. This is your simple data step, starting with data and ending with run. This is your proc step, starting with proc and ending with run. Select and submit. See, always the character variables, missing character variable values will be represented using a blank space. The numeric missing variable values will be represented using a dot. Open this dataset, see, here dot is present, but here nothing, a blank space will be there instead of that missing value. This is how your numeric variable values and the character variable values will be represented. Now see how SAS is reading these values. If we are printing this one, it is printing the data correctly, right? It is assigning the value 101 to ID variable, and then this value to this variable, and then this value to the age. So it is reading in an order. Okay. After completion of first line, after assigning all these three data values to these three variables, then by defaultly it is coming to the second line, and again it is assigning this value to the ID variable, and same way salary is 2000 and age is 35. So after completion of first variable, it will defaultly comes to first observation, it defaultly come to the second line. So this nature is called flow over. So flow over is the default nature of the SAS. Suppose, see, if your age value is missing, now how it will read the data? Run this and check. In an output window, you are getting only the first observation. Why? Because first value is ID P101, it is reading. Second value it is reading. Here third value is not there. So here SAS is not finding any value. So it is coming to the second line and it is taking this value. But here I declared age as a numeric variable. But the value is a character one. So it is not taking the value. So you are getting that dot. As numeric variables will be represented by dot, it is showing you that dot. Okay. How to overcome this problem? You can use in-file statement. In-file can't miss over. This miss over option will stop the SAS to go to the next line. If the value is missing here, it will take it as a missing value. It stops the SAS to go to next line and read this value. Now run this. You will get the data correctly. It is reading the data correctly. If you are not using this in-file cards miss over, here your missing value will be represented by dot. Either you should represent that missing value or you have to use that in-file cards missing over. Now also it reads the data correctly. So in-file cards miss over. Now let's see. This 1000 is also missing. Now run this. Same way you are getting, it is reading the data correctly. Why? Because this value is assigning to ID and then here the two values are missing. So this miss over is preventing SAS to go to next line to read these values. Instead of these values, suppose if this value is missing, 1000 is missing and we are having the age as 25. Now what will happen? It will read ID. Now salary. There is no salary. Then which value it will take? Run this. See, it is taking salary as 25. Why it is taking salary as 25? Because the second value present here is 25. So it is taking salary as 25. And here it is thinking as age is missing. This miss over option is used only for the values where the last variable is missing. Variable value is missing. Or the both. Okay, only in these cases only this miss over option will work. Only at the end of the line if your values are missing, then miss over will prevent the SAS to go to next line and reading these values as the first observation. In other cases like this, we have to represent with dot. Now SAS will consider this dot as a missing value for salary. Same way, see, now my data is present here in SAS. Okay, suppose if my data is outside the SAS, how to bring that into the SAS? How to read that data? Using here to read this missing, there also will use this in-file statement. Let's see how to do that. Data new to in-file. Just give your data notepad where it is present. See, I am having my data notepad here and same values I am having here. Okay. Now take the path of this. Go right click, go to properties, security and copy this path. And close this. Copy here, give this semicolon and give input. What are the values? ID, age or salary and then age. Run. Now you will get the data, whatever is present in this my data, the same data it will read into that SAS. It is reading through this path. Now open this new to check whatever the data present in that my data folder, the same data it is bringing into the SAS by depending on this file. Okay, whatever the data present in this path, using the in file, we can bring that into the SAS. Same way, instead of giving in file here, how we are creating the library name using lib name. Same way we can create a file reference also. Like how we are creating the lib reference, library reference, same way we can create a library reference using file name statement. File name, give the file reference and then the location. File location. Okay, this is the syntax for the file name. So follow that. Write file name, just give one reference. I'm reading it as car. I'm giving my file reference as car. Okay, and then give the path, same path. Now run this. So now you have representing this path by the word car. Okay, now the same thing you can do here also. You can bring the data using that file reference also. Data new 3 in file. What is your file reference? It is car. Input remaining everything is same. ID, salary and age. Run. Now run this. See, now also it created a data set with the same data. Whatever the data present in that, it is giving you the same data. Okay, either way, these are the different ways how you can create your data sets or how you can bring your data from outside SAS into the SAS. This is one way. Either we can keep the data here in this data set in the data step directly like this, or else if it is the outside the SAS, if the data is present outside the SAS, then using the in file statement we can give that path and then we can bring that into the SAS. Okay, same way how we are creating library reference using libname statement, the same way we can create a file reference also. So instead of giving that path, here this path I am representing with the word car. Okay, so that car here I have used that. Same way here, think if your data is missing, last observation or last value is missing for that observation. Now how to read that? Same way here, how here we are using miss over if my value is missing at the end of the observation. Same way here give your miss over option. It works same. Here also file car miss over. This is how you read the data. What is this blank space? How the SAS is separating your values? It is reading P101 as ID and salary as 1000. How it is reading? Because the values are separated by using a blank space. So this one we'll call it as delimiter. We'll call it as delimiter. Blank space is the default delimiter. Okay. That's why it is reading only this value for ID and this value for salary and same as this value for age. How it is reading? Before the blank space as one value and after the blank space as another value. It is separating, delimiting. That's why we'll call it as default delimiter. Okay. Now if my data is having multiple blank spaces, then how it reads the data? Will it read in the same manner? Yes. Let's try this. Now open this new one and see. See, now also you got the same data. There is no difference if you are having multiple blank spaces or a single blank space. But these values should be separated by at least one blank space. Now what will happen if it is like this? See, first SAS will assign this value for the ID and then it checks for the value, for the next value. It goes through all these blank spaces and then it finds this value here. So this value will be assigned as a salary. And again SAS goes through all these blank spaces and now it encounters this age 25. So now this 25 will be assigned to age. Okay. There won't be any difference if it is having a single blank space or multiple blank spaces. But the data should be separated by at least one blank space. Because see, if your data is like this, can it make difference what is ID, what is salary and what is age? It cannot, right? So it should be separated by at least one blank space. Even if it is having multiple blank spaces also, it won't make any difference. It reads the data correctly. Suppose if you want to save this data in two data sets, how you will save? I told you we'll give the data set name in the data statement, right? Here new one is one data. Okay, I want to create another data set with the same data. Then give it as new 4. Already 3 is there. So now you will get the same data, whatever is there in this data step, the same data it will give to you, new one and also the new 4. Now run this. Open new one. It is having the same data and also new 4. It is also having the same data. So like this you can create multiple data sets. Whatever the data set names you want, you can create that data set. You can give those data set names in the data statement. So this data will be assigned to all the data sets. Like this is a simple list input method. Like this we are having different methods, input methods to create a data set, and also we are having an output method. So all these things we'll discuss in the next video, different input methods and output method. And also we'll see how SAS reads its date values.
Yes, I got some doubts.
Yeah, tell me.
In SAS, can we do any certification?
Yes, you can do certification like Base SAS certification, Advanced SAS certification and all. Okay.
Okay.
Yeah.
Is this a global certification?
Yes, it is a global one. So you can do in any country, wherever you are, you can do in that country. Just register online and you can book the slot for your exam. Okay, just place and time.
Okay.
Okay.
Okay. Yeah. If I join this course, can I get the software?
Yes, you'll get the software as well. Along with the material, you will get the software.
Okay. How long this course will be?
It will take around 30 to 35 days.
Okay.
Mm.
Okay. If I get any doubts, can I get back to you after even after training?
Yes, you can get back. You can mail me at any time. Okay, either you can WhatsApp or you can mail me. Okay, it is not like that during the course only we'll take care
Okay.
of you. Okay, even after the training, if you get
Okay.
any doubts, you can get back to me at any time. Okay.
Yeah. Okay. Yeah. That's it.
Yeah. Okay. Then how is the class? Did you like it?
Class is very nice. Yes,
Okay.
I like it, and it is very. I can easily understand
Mm-hmm.
what you're telling also.
Okay. Thank you. If you want to register for live demo, please go through the link in the description box. Please subscribe for more videos. Thank you.